All right, everyone. Thank you so much for coming tonight. Super excited. I've just been looking up to check where everyone's from. Really glad that you all decided to be here with us tonight. We'll go ahead and get started. So tonight's workshop is called Start Seeing in 3D, Discover NGSS Agriculture Phenomenon. And we're glad you're here. Before we get into discovering NGSS 3 dimensions, let's talk about the norms for today's workshop. Make sure you're muted until you see the microphone icon. You are welcome to use the chat to share your thoughts and ask questions. My colleague Sarah will be monitoring the chat throughout tonight's call. We will be collaborating in breakout rooms. Just like you would expect your students to be collaborative and engaged and kind, we ask you to do the same. Finally, download the takeaway document for tonight. We are dropping in the chat. So let's go ahead and get into it. There's that takeaway document for you. All right, so let's start off just by sharing why you are here today. Where it's at tonight. So take a moment to join in on it. When you see the chat bubble on the screen, make sure to share your thoughts, questions, and ideas. Let's start by sharing why you decided to come to tonight's workshop. And again, you can go ahead and put that response right in the chat there. New ideas, excellent. Thank you, Atkins Acres. Charter school. This could probably use some really good new ideas. Engaging lessons for agri-science classes, awesome. New teacher to you. You will definitely want to gain some insights and hopefully you'll be able to take some things out of tonight, Ryan. Yep, something different, ideas. Oh, that's interesting. Yep, Pennsylvania and your new NGSS standards, excellent. You are in the right place for that. Love that we have a couple of connections there in the chat about STEM and STEM connections. Shout out to the department chair who's looking to gain insight. That's great. Way to be super supportive for your staff. Awesome. These are great. I think these are all awesome reasons for you to want to be here. And hopefully we can deliver on some of the things that you're looking for this evening. So our goal today is for you to walk away with confidence in identifying high quality phenomenon that incorporate agriculture topics to be used in science classrooms. We also hope that you will learn how to choose science and engineering practices, disciplinary core ideas, and cross-cutting concepts that align with agriculture phenomenon. So before we get going, I should probably introduce myself and welcome you to this workshop. My name is Angela Galata, your facilitator this evening. I have 17 years of teaching experience in middle and high school classes across both Illinois and Wisconsin. I've had the privilege of bringing subjects like physics, engineering, biology, and just general science classes to life for many of my students. I love being able to share my passion for science and make learning exciting and engaging for everyone in the classroom. Nowadays, serving as a learning analyst where I'm putting my skills to use on agriculture-related NGSS projects. I'm always on the lookout for new and innovative ways that we can help teachers and also students grow. And I'm thrilled to be working on projects that are making a real difference in the world of education. Today, we will be working together and also individually to make sense of the 3 dimensions of NGSS using agriculture phenomenon as a context. So we'll go ahead and get right to it. All right, so tonight we're going to start with story time, everyone. It's my favorite. It's like put your kids to bed. Here we go. Ready? Once upon a time, there was a little girl named Quantum Locks who loved to explore the world around her. One day, she decided to go for a walk in the forest and see what she could discover. As she wandered through the trees, she came across a small cottage. Quantum Locks was curious and decided to investigate the cottage. She used her senses to observe the outside of the cottage, looking at its size, its shape, and its color. She listened for any sounds and smelled the air to see if she could detect anything unusual. She also used her engineering skills to try to open the door and see what was inside. So let's take a moment to connect what we just heard about quantum locks to how that relates to NGSS. So which of the three dimensions of NGSS did you hear in this part of the story? You can go ahead and write your answer in the chat. They would be DCIs. Do you think they were SCPs? Or do you think they might have been cross-cutting concepts? And remember, she was using her senses to investigate, analyzing what she observed, and was obtaining information. So these were things that she was doing. So go ahead and drop your responses in the chat. SCPs, DCIs, cross-cutting concepts, whatever you think. If you're not sure, totally okay too. That's why we're here. Great, SCPs and CCCs, SCPs, observing, making sense. Okay, SCPs, awesome. Cool, CCCs, yeah, the SCPs, the CCCs, they're always kind of they go a little bit hand in hand sometimes, lots of crossover there. Awesome. All right, thanks for putting all of those responses in the chat. We'll let those keep coming in as well. So now let us know in the chat, where do you see these types of actions in your classroom with your students? Activities in your daily lessons, awesome. Sounds like an engaging classroom. During labs and investigations, really great job there. Yep, looking at research, looking at any kind of data elements, when they're applying topics or when they're engaged in investigations. Excellent job there. These are great, everybody. Thanks for letting those roll through. Yep, analysis and figuring out phenomenon. Looks like you're in the right place there. Woohoo, that's exactly the response, the kind of response we want to hear. So thanks for sharing all of those responses. You guys were on the right track. For this one, we were going with science and engineering practices. We call those SCPs to see how the things in the cabin associate with quantum locks goals. SCPs students do. In this case, it describes how quantum locks is using her curiosity to investigate the cabin using all of her senses. She obtained information about the cabin and some of the things that might be inside it. She observed function of items like the door by experimenting, and you can see that every day in your classroom with your students. Let's go ahead and get back to the story. As Quantum Locks explored the cottage, she noticed that everything inside had a relationship to something else. The size of the furniture was related to the size of the room, and the texture of the objects were related to their purpose. She also noticed that the temperature inside the cottage was related to the size of the windows and the type of insulation that might have been in the walls. So now let's think, we already looked at SCPs. What do we think this sounds like? DCIs or cross-cutting concepts? You can go ahead and type your in the chat. Love that. CCC, pattern, structure, function, excellent. Scale and quantity was in there as well. So I think we're all on the right track here. Nice work. So now we want to challenge you, just like we did before. How would you see these actions in your classrooms with your students potentially? Go ahead and drop that response in the chat. And totally okay if you don't know yet, not a problem. Thanks for being here and being open to learning. Yep, so the question is just how would you see those cross-cutting concepts such as like pattern, scale, quantity, structure, and function in your classroom? Love that. Yes, Leslie, how things are related, providing scenarios, asking questions, data analysis. Again, that's why I think sometimes it's really tricky to go between those SCPs and those cross-cutting concepts. But maybe if you had been able to go through the whole story first, it would have made a little bit more sense for you. Yeah, connections between your life into the concepts. These are awesome. Great. So again, thank you for sharing those responses. We're going to get back to the story now. Quantum Locks was working to connect what she was seeing, feeling, and sensing to other contexts that she knows. Quantum Locks was using cross-cutting concepts. Those cross-cutting concepts help us see how students think. In this example, we are seeing her observing flow with the temperature in the cabin. She also made a connection to scale when observing the size of the furniture in the cabin. She's making sense of the scene, right? Awesome. All right, so finally, Quantum Locks discovered the 3 bowls of porridge on the table, each with a different temperature. The first bowl was too hot. The second was too cold, but the third one was just right. She wondered, how can that be? They're the same, but different. She also found 3 chairs, each with a different size. The first chair was too big, and the second was too small, but the third was just right. She also found 3 beds. Each one had a different softness. The first bed was too hard. The second was too soft. The third was just right. So now that we know these are DCIs, right? We already know that we had our SEPs and our cross-cutting concepts before. What attributes did you hear in that story that you think might target those DCIs? Why would these be DCIs? Go ahead and drop those responses in the chat. So again, what makes these DCIs? Yeah, observations that are qualitative and quantitative. She's relating ideas. Yeah, observations and inferences that are connected to the environment. Great ideas. I'm loving all of those. Thank you. All right, so where in our classroom might we see DCIs coming into play? Like, what's the responsibility of DCIs in our classrooms? What purpose do they serve? Go ahead and drop those responses in the chat. Yes, state tests. Yep, connecting observations, using and understanding everyday phenomena. Awesome response, Christy. Yep, comprehending big ideas. So these are like the things they need to know in the classroom, right? Like they kind of got to know stuff. And I think like state tests and understanding how to navigate through science is important as well. Yeah, system interactions. When these responses come through. Yep, so Quantum Locks got into the details of the cabin in this part of the story. She focused on what she saw. Quantum Locks really leaned into the details of the world around her. She was observing and making connections using disciplinary core ideas. This is what a student like Quantum Locks knows. She investigates topics like energy transfer when testing the temperature of the porridge. She was even able to investigate engineering principles when finding just the right size chair. And so Quantum Locks learned that just like there is no one perfect bowl of porridge or chair that fits everyone's needs, there is no one scientific dimension that can fully explain complex phenomenon. Instead, we must use all three dimensions of the next generation science standards together, just like the three bears, bowls, chairs, and beds to understand the world around us. By integrating disciplinary core ideas, cross-cutting concepts, and science and engineering practices, we can find the just right approach to scientific inquiry, one that and truly engages learners in the process of discovery. As Quantum Locks walked out of the bear's house, she knew that her journey to explore the wonders of science had only just begun. And this, friends, is just a simple example of what you get to experience with your students as you begin to implement NGSS into your classroom. Sorry, just checking on the chat, making sure y'all can hear me okay. Let me know if it's problematic again. Sorry, guys. Technology, am I right? Technology. All right. Quantum Locks was truly trying to find answers as she entered the Bear family house. She was trying to find a place to weather the storm, feed her hunger, and grab some Z's. When we are teaching students science, they are doing the same, and they are doing this through sense making. Let's break down that compound word. Sense as a verb is defined as grasping the meaning or understanding. Making as a noun can be defined as the means or cause of advancement. So essentially, when sense making, our students are grasping the meaning of something to advance their knowledge. It's pretty cool. In NGSS materials, sense making is supported by four critical attributes: phenomenon, science and engineering practices, student ideas, and grade appropriate science ideas. All four things combined support students as they make sense of phenomenon and or design solutions to problems. Let's take a moment to review what the four critical attributes of sense making mean to you. Let's start with phenomenon. Type in the chat what you know about phenomenon in the NGSS space. Natural occurrences, awesome. Yep, making sense of the natural world, an occurrence in the natural world, an observable scientific event that you can explain. These are excellent responses. Authentic experiences, yep. Yep, something that might inspire curiosity, yep. So sure of the explanation yet, so yeah, excellent. Okay, awesome. Yes, you guys, a phenomenon is an observable event that can be explained through science. In sense-making lessons, students experience a phenomenon like exploding seeds or worm poop through firsthand experiences or media. They then get to share their noticings and wonderings with the class and chart a path forward to investigating their phenomenon. These phenomena were found on the NGSS phenomenon website assembled by Dr. TJ McKenna. We have linked this on your takeaway document. Okay, so next up we have student ideas. What do you know about the importance of students' ideas in NGSS curriculum? Go ahead and type a response in the chat. Yes, absolutely essential. Love that. So what else do we know about student ideas? Yep, promotes peer discourse. Awesome. Thank you, Carrie. Students are acting like scientists, so their ideas drive learning. Yes, I got that question at least 1,000 times for 17 years. Why does this matter? So glad to see that even though I'm not in the classroom, it's still a thing, right? Misconceptions need to be cleared up and it builds on familiar experiences. These are great responses. Thank you. So student ideas allow students to be the true scientists in their learning experience. According to NSTA, students cannot fully engage in the rest of sense-making criteria without the opportunity to share ideas, build on each other's ideas, provide feedback, and change their minds. This also helps students that their ideas are valued and important. Moving on to number 3, what do you know about science and engineering practices in the NGSS space? Go ahead and share your response in the chat. No, we've talked about it already, but let's see if we can come to consensus on what that might be. So again, what do we know about science and engineering practices? Yep, what students do, fact-driven, foundation for exploration. Yep, they provide a system, provide a framework. Yeah, practices that scientists use to solve problems. Awesome. Yeah, great job. The sense-making process has students engaging in science and engineering practices. These skills that they engage in help them make sense of what ideas they need to notice to help them explain the why or the how of a phenomenon. Some SCPs that you might have heard about before are the ability to analyze data, engage in arguments from evidence, or even developing and using models. The last part of sense making is science ideas. What comes to mind when you think about science ideas? Go ahead and drop this response in chat. Oh, yep, Lauren, Sarah just dropped that in there for you. So wonder, curiosity, great words, Kimberly, great. Connecting ideas to other scientific contents. Yep, content in itself, absolutely. Awesome ideas. Yep, science theories that explain what students are observing, so that phenomenon. Thanks, Cindy. So thanks for sharing those responses. In the past, standards were the only driver of science education. Students need to learn and know them through repetition, and that's how it was before. Well, in NGSS instruction, these DCIs are important, but not without the other three criteria that we had chatted about earlier. DCIs are a key tool in NGSS instruction and can be taught over multiple grade levels at progressive levels of depth and complexity. Okay, so now it's time for us to give you a little bit of a challenge. Before we get into phenomenon, we're going to give you this challenge. We're going to put 5 minutes on the clock. During that time, head off to Google to research and generate a list of ideas that are related to agriculture that can be explored in the science classroom. Now, if you're not 100% sure of what to look for or where to find it, no worries. Just go for it. When we return, you will have time to check your work. Lean into learning. And again, remember, you have 5 minutes to gather ideas of agriculturally related phenomenon. What questions can I answer before we start the timer? All right. You can just jot that list down. You need it a little bit later on. So just hang on to that list. You can type it out. You can hand access to it a little bit later tonight. Any other questions? To sell curriculum? Nope, I don't sell a thing. What we're hoping tonight is that we give you a little taste of how you can use agriculture in the classroom. Nope, you could just write the list down. You don't need to drop it into the chat. All right, we'll go ahead and get started with our 5 minutes. If you do have any questions, the chat's open there. Feel free to do that. So again, don't need to worry about where you put that list. You just need to have access to it a little bit later. So we got a little less than a minute there. Probably a good thing. Christy said she's running out of room. So take about 45 more seconds to jot down some thoughts. And thanks for everybody that's dropping ideas into the chat. Super helpful for everyone else. And we'll circle back to those later. All right. So again, thanks for taking the time to do a little bit of brain work there and kind of dive into some agriculture phenomenon. Let's review what phenomenon is as defined by NGSS. So I know we've talked about it just a little bit before, but what's one word that comes to your mind when you think of phenomenon? Go ahead and drop that in the chat. Just one word. Cliffhanger. Love that. Theme. Awesome. Connection. Amazing. Observation. Overarching concept. Wow. Like that one too. Curiosity. More observation. Yeah. Great. Yep, something that can be explained. Yep, we hope so. Just hopefully by our students, right? Yeah, marvel. These are all excellent descriptions. All right, so we know that phenomenon drive NGSS learning experiences. They're also used to motivate student learning. They are real world problems, and their purpose is to focus the materials and instruction on the phenomenon. So, as a reminder, though, not all phenomena are productive for student learning. Phenomena need to meet the standards that have been set forth by NGSS. So take a moment to look through this more like, less like chart. This is from the critical features of instructional materials design for today's science standards, which is by Ed Reports and Next Gen Science. A link to this is on your takeaway document. As you're reading, choose one thing that really stands out to you as different from your current or your past teaching style, and go ahead and share that in the chat. So again, what really stands out to you as being different in NGSS instruction? Oh, well, great. Yeah, so then you're all in that more like column. Awesome, Christy. Yep, student-led. Yep, even if you don't teach NGSS, how does that NGSS idea, that shift of phenomenon-based learning, how can we see that appearing in a classroom? Like that more like column, how does it look a little bit different than traditional science classrooms in the past? Yep, discussion, inquiry, super organized, definitely very, very student-centered. Critical thinking skills are there because we're bringing in those SEPs and also those cross-cutting concepts to reach across more even outside of science. Definitely engaging, absolutely. Awesome. Yep. Less depth to content, more understanding of process relationships. Yeah. So big picture ideas versus needing to memorize and know every single little detail. Yep. We've used learn science facts, then now they're learning to be scientists. That is an awesome snaps for that. Yeah, big time. That was great. Yep. The question is before the answer. Yeah, absolutely. Great. Lost my mouse. Sorry, guys. My mouse always hides. After what we have learned, let's go ahead and test our knowledge about phenomenon and how it works alongside learning goals. So in a moment, a question will pop up as a poll in Zoom. Go ahead and click on either true or false. So we're going to do 4 questions. So if you're ready, here is question number 1. So the first thing we're looking for is true or false. Disciplinary core ideas explain phenomenon. We're going to open up that poll and you can go ahead and respond. Oh, I will see what's going on here. 1 second. While we're waiting, you can go ahead and drop true or false there in that chat if you want while we figure out what's going on with polls here.
The polls look like they're working. I have 22 answers.
Okay, cool. I'm like, mine aren't showing up, so glad that they are working.
It is.
Okay. You know, nothing like a little freak out moment, all good. But if you can't figure out what's going on with polls, if you're having the same issue with me, just go ahead and drop that then in.
Okay, I'm going to end the poll and share the results.
Okay.
So it looks like we have 65% have said true, that DCIs explain phenomena, and we have 35% that said false.
Awesome.
Let's tell them the answer, Angela.
Sure thing. So yeah, this one was true. DCIs, or disciplinary core ideas, are used to help students explain a phenomenon or design solutions to a problem. But remember, that's only one part of the picture for that explanation. But they are using science ideas, or DCIs, to explain them. Okay. That was like, we were just getting the rust off on that one. We're going to get 100% this time. Here we go. All right. Here's number 2. Students should be able to explain phenomena without using or developing some of the targeted DCIs.
We have 13 answers. Let's get some more in there. All right, give you about 5 more seconds. Just take a guess. We don't see what you say. We just appreciate that you're participating.
Absolutely.
Just like we love when our students participate. Oh, I had to exit out of the poll to read the question. Totally understand. We'll make sure we repeat it a few times. All right, ending it now and sharing results.
Yeah.
And for Angela, we had 69% said false and 31% said true.
Love it. All right, well, let's show them. This one, it should be over more on that false side. Kind of looks like it's a little in the middle there on the screen, but this one was false. When a unit or a lesson targets a DCI, that means that that DCI is necessary for the students to use for sense making and for problem solving. So it's like we don't want to use DCIs or have them like visit standards that just aren't part of that sense making process. We want to make sure everything is what we call aligned. All right, let's head to number 3, which is DCIs aren't needed when discovering engineering-based problems or phenomena. So again, just in case it boots you out when you're on the poll, DCIs aren't needed when discovering engineering-based problems or phenomena. True or false? Okay, how we doing on responses, Sarah?
Give them about 3 more seconds.
Always just like to make sure they're actually coming through.
Yes, they sure are.
Beautiful.
All right, with 24 responses, we will end the poll, share our results, and we had 79% said false and 21% said true.
Ooh, all right, well, let's show them what it is. All right, this one did the same thing. Should be scooched a little further to the right there. But this one is also false. Engineering lessons require students to obtain new understandings of physical, life, earth, and space science to solve design problems. I mean, can you imagine developing a prototype or a potential solution for an irrigation system without foundational knowledge in maybe soil science? I don't know, little physics. I sure couldn't. So that is what is so exceptional about NGSS. It puts together the core ideas you need for real life. We know as adults and educators, you don't just need one skill set. You need a combination, and that is what you give your students when you provide NGSS aligned lessons. All right, we've got one more. Let's see how we do on this next one. This one is all targeted DCIs are necessary for sense making and problem solving. So again, in case the poll covers it up for you, all targeted DCIs are necessary for sense making and problem solving.
All right, we're getting up in our 20s. Another second or two, and I will stop it. Angela, I think for this one, if you had to everyone who answered, look at the question, the key word for me in this one is targeted. Targeted is the one that stands out to me, that helps me choose the right answer, which the right answer is what, Angela? It's not going.
The right answer for this one is true. So like we said earlier, students use grade appropriate DCIs from life, earth, and physical science together with the elements of the engineering DCIs to solve problems that are related to design. So again, I think Sarah nailed it there. It's when we're targeting a DCI, that means that we expect a student's response to be aligned to that DCI. Okay. And then Carly, your question in the chat was needed by the student seeing the phenomenon or by the teacher finding it. So all of the things that we were talking about is related to student sense making. Obviously, a teacher would need to have some of the ability to bring a student to that point if it wasn't quite perfectly identified. So I don't know if that answers your question because I don't know exactly where it fell there, but cool, thank you. All right. So we have done a lot, right? I don't know about you, but I feel like I just need a moment to kind of get my thoughts together here. So we are going to take just a short break. You can turn, hop up, stand up, stretch, whatever you need to do. We're going to set a 5-minute timer just to break up the evening a little bit. And then when we get back, you are going to be getting some collaboration time in some breakout rooms. So it'll be me doing a lot less talking, which might not be a bad thing, right? So we'll give you 5. Welcome back to everybody that's coming back. Got a couple more seconds before all of those rooms close there. I never know if I should leave the breakout room or just wait for it to kick me out. I'm one of those, like, I'm never sure what to do. So, like, there's a right answer to that.
Can you be our talker?
All right, I think we have pretty much everybody back here. Awesome. So again, we sent you into those breakout rooms to chat about the lists of agriculture phenomenon that you gathered earlier in the evening. And we wanted you to kind of like sort through some of the things that you were able to find together and identify together there. So now we're going to do a little bit of a share out. So if there are any groups that do want to come off mute and share, we are more than happy to have you do that. If you are that group that like now you did what you needed to do and you're cool just dropping it in the chat, have a representative from your group go ahead and do that. We are probably, in the interest of time, not going to have everyone be able to share out. We'll get to as many groups as we can. I think we had like 6 or 7 maybe. So we'll see if any groups want to come off mute. And again, no pressure though. You can just drop it in the chat if you want.
Group 4 was going to come off mute.
I love that. Thanks, group 4. You can go ahead and get started then.
Nobody wanted to be a scribe, so we all just said we'd talk. So we went all over the place with this, from environmental impact and ecology with watersheds to structure and function, including cellular organization and digestive systems between ruminant and non-ruminant organisms. We talked about genetics, things like artificial selection and hybridization and all kinds of stuff. There was very little that we didn't, and our group was mixed, all kinds of backgrounds and experience levels. So it was a good group.
Great. Thanks, Carly, for sharing. Anybody else want to come up and share? Again, if you don't want to do that, you can go ahead and drop some ideas in the chat for everyone.
Yeah, anything I missed, feel to jump in, group 4.
Thanks, Carly.
I could come off mute. I don't know what group number we were, but there were 3 of us in there. We did come from various backgrounds as well. I believe one was a social studies teacher and the other was an art teacher, and I'm an integrated math and science teacher at the middle school level. But we talked a lot about sustainability, how renewable energy practices perhaps on the farm, the rise of solar farms and the versus land space for agriculture. Methane capture was one thing we mentioned, use of pesticides and fertilizers and how that affects algae blooms. Water conservation is huge because obviously farms take up a lot of water. We're becoming sparse in our potable water or drinkable water. Let's see what else. GMOs, artificial selection. When it comes to breeding, you get these huge muscular cows versus what they were back in 1950s. And then the interesting thing that I think we brought up was there's a big push to try to promote agriculture. How can we sustain agriculture on other planets like the moon or Mars? I think a lot of kids would find that interesting. And I think the last topic mentioned was the effects of invasive species on the land. So if anyone else wants to chime in on our group from my group, then go right ahead. But I think I got them all.
That was good.
All right, cool.
Awesome, Carrie. Thanks so much for sharing for your group. It sounds like you guys had some really good conversation in there. Love that. Any other groups have anything that they want to add to the conversation here? Anybody brave enough to come off mute?
I'll go for my group. I'm gonna do a quick list because a lot of stuff was said. I mean, some of the things I didn't hear were like irrigation kind of design, weather systems, infectious diseases, contaminants, geothermal conditions, thinking about climate change, water and soil composition, teaching them how, they have to analyze all of that to be able to, produce what they want to produce. And we talked about GMOs. We also talked about how all of this can give an opportunity for cross-curricular to other disciplines like social studies, math, and even ELA, and how all of it kind of interweaves, which is really just the overall concept of next gen. So food systems and I loved the agriculture on other planets. That was awesome because I actually did a huge lesson on that with my 8th grade kids about 2 years ago. And it was great. I used the concept of colonizing other planets to explain and let them understand. In order to know how to live there, we had to first know how we lived here and how we grew food, how we were able to breathe air, how we were able to create water, and all of that fits right in with agriculture.
That's a great connection to social studies too, because you can talk about
Mhm.
historical colonialism for food like Japan. So social studies definitely has a place here.
Listen, it brought up huge social studies issues because you would only be able to bring so many people to another planet. Who do you bring first? Who do you exclude? Who do you have to have in order to start and sustain an economy, a food system, a hierarchy, just everything about the way we live? And then who gets to decide? And then think about how this sparked world controversies when we try to just get into space. What's going to happen when we decide to colonize a planet or the moon? Like if we think you saw world wars before, wait till that happens, right? Where's my social studies friends?
Oh yeah, absolutely. And as you're saying that, one of the things that I try to connect with my students, again, I'm just a social studies teacher, is recently with Greenland and how Greenland wants to be independent from Denmark and Antarctica and sovereignty claims. I think there's a lot of things that our students can connect with in this world with understanding agricultural issues that connect to topics that they may not be expecting, like political. So yeah, absolutely.
Yep.
It's actually a really great DCI connection. There's a DCI that ties to how human interactions and human resources build upon the understanding of like geopolitical and social and cultural costs. So Sarah and I are living in that world right now in one of our projects. So to everyone shared tonight, great to hear that agriculture is bringing so many things up for everyone. This is really awesome. Loved hearing those. And thanks to everyone that was putting things into the chat as well. Hopefully you get a chance to scroll back through those. So, all right. So now that we have that list, we're going to take some time to look at resources that you can use when you're trying to find phenomenon that help to drive student learning. So we're going to tell you straight off that these are not all agricultural related, but you want to screen for any that do have that ag connection. As you guys were talking earlier, there's so many different ways that agriculture can be brought into the classroom and through many different contexts there. So we're going to give you some individual work time. And while you are in that work time, you're going to investigate 2 websites that you may or may not have seen before. But your goal with this search is going to be twofold. The first one is to find phenomena that are similar to some of the things that you came up with earlier in your groups. And then the second is to find phenomenon that align to things that you actually teach, and that you would be able to, maybe with a little bit of extra love, just drop right into your classroom right away. So those links are on your takeaway document, and they are also, oh, Sarah just put it in the chat. Never mind. I was going to say, we'll also have them in the chat there, but she got that takeaway document. And so we're going to go ahead, 5 minutes of time, just to go ahead and kind of browse those sites, see what you can come up with. Again, try to pick out any that are agriculture related. You don't have to write anything down unless you want to. We're not going to do a specific share out or anything with these, so you can go ahead and just keep them in whatever format you want. So can I answer any questions before we get started with our timer? All right, then we will go ahead. If you have any, as you're exploring those sites, those 2 sites again are the NGSS phenomenon site that we mentioned before, and then the Wonder of Science phenomenon site as well. So you have those on that takeaway document, and we'll give you some quiet time to work. All right, everyone. Well, thanks for taking that time to work. Tonight, we wanted to try to give you some independent time and some time to put some thought around phenomenon. So if you're willing, just drop a word in the chat to describe how that search went for you. How do you feel after you did a little exploring to investigate potential phenomenon that you might be able to use? I think everybody's still too excited exploring the content there. Good ideas in the chat there. Okay. Lauren, I saw in the chat you sent me a message about the credits that you can earn for the professional developments. And at the end, we do have a survey that you can take that just lets everybody know, like on our end, that you were here. And then there are potential CEUs for these as well that you can accumulate. So How that specifically works is state dependent though, and I am definitely not the person to ask about that one, but that survey would be a great start. So in case anyone else was curious about that as well. Awesome. Yes, I agree with whoever just posted about the rabbit hole. I set a timer because I get stuck doing the exact same thing. So totally understand that. All right. Well, thanks again for putting those responses in there and for bearing with us here as we explore phenomenon stuff. So let's talk a little bit about choosing phenomenon. So when we are focused on selecting phenomenon for our classes, it's important that we remember that phenomenon can come from teacher ideas, from student questions, and other related phenomenon that you've already explored in your classroom. So we're going to take a look at a couple of examples tonight, and we're going to kind of let you do a choose your own adventure here. So here are 4 potential phenomenon that we could explore this evening a little bit more. And we just wanted to not be the ones to select and pick. And we are going to have a Zoom poll that's going to pop up in just a moment, and then you can choose the phenomenon that most interests you. Tonight, we will be discussing the top 2. So again, you have the option of the hamburger meat turns brown when it's cooked. Most of the world buys their milk at room temperature. Cattle are helping save birds in the Great Plains, and biotechnology allows for the development of more efficient beef cattle. So Sarah, if you can let me know what's rolling in there.
It is going. We have
The votes.
10 responses, 12.
Angela, did you say we could only pick from the top 2, or we can pick any of the 4 and the top 2 are
You-
what's going to go?
You can pick any 4 and we will choose. We'll go just with the 2 that are the top for the group tonight here.
Gotcha.
Yep. Sorry if that was unclear. I'm very good at giving like backwards directions. Just ask my husband, I'll tell you.
I'm listening and reading at the same time, so
All good.
yeah.
Usually it's me. I just always default to myself. So Sarah, how are we doing here?
We have 76%, and I will call that a majority. So we are going to end the poll. I'll share the results, and it looks like we are going to be exploring room temperature milk. Most of the world buys their milk at room temperature, and also biotechnology allows for the development of more efficient cattle.
All right.
So here we go.
All right. So most of the world buys their milk at room temperature. So you know that milk is pasteurized, right? So the process that heats milk to kill bacteria, that's what pasteurization is. That bacteria that is targeted to be killed off is pathogenic and spoilage bacteria. Well, in Europe and in other places in the world as well, the pasteurization process is different than what is used in the United States. Because it kills more bacteria, it allows them to make milk shelf stable for approximately 6 months if it's left unopened. Well, how does that happen? This sounds like a great phenomenon that you might be able to explore with your students. This phenomenon specifically has DCIs that are connected to high school and middle school grade bands that could potentially be explored. So if you like it, you can turn this into a potential phenomenon for your classroom. The other one that was our second, I don't know which one was first choice and second choice, but this was in the top 2 there, is biotechnology allows for the development of more efficient beef cattle. So cattle producers use artificial insemination that allows producers to breed more efficient beef cattle based on their needs. Maybe their herd needs to improve carcass weight. So there's a way that with breeding practices, you can achieve that goal. Cattle producers can choose certain traits that they wish to see and breed to attempt to get the best probability for that trait to be present in future generations. This particular phenomenon is great for middle school and also high school DCIs. The examples that you just looked at are beef phenomenon which was produced by the Beef Checkoff, who's sponsoring us this evening. This resource is available completely for free on the Food and Agriculture Center for Science Education. We've linked that resource on your takeaway document. I think it's the very last one on the takeaway document there. But this phenomenon toolkit is useful in starting the phenomenon process of outlining. And that's what we're going to work on teaching you here in the remaining time that we have. So we've had time to review phenomenon, brainstorm possible phenomenon, and learn how to use them in the classroom. So we are going to revisit those phenomenon examples that we chatted about at the beginning of the workshop, and also potentially these couple that we just looked at here. And we are going to challenge you to create an anchor phenomenon experience. But before we do that, we need to review the critical features of an anchor phenomenon. Anchor phenomenon are the focus of an instructional unit and requires multiple lines of evidence for explanation. So here are the top 9 things that you need to know about anchors before we get started. A good anchor builds upon everyday or family experiences, who students are, what they do, and where they come from. It's important that it is compelling to students from non-dominant communities, English language learners, cultural groups that are underrepresented in STEM, and so on. A good anchor will require students to develop understanding of and apply multiple performance expectations, while also engaging in related acts of mathematics, reading, writing, and communication. Number 3, a good anchor is too complex for students to explain or design a solution for after a single lesson. They're going to really have to explore to get into the details. Number 4, the explanation of a good anchor is just beyond the reach of what students can figure out without any instruction. So what that means is that students can't just Google it and get the correct answer for them to copy down. Just needs a little bit more. They need a little bit of guidance in that. Number 5, a good anchor is observable to students. Observable can be with the aid of scientific procedures, such as doing something in the lab or some kind of a technological device so that they can see something at a very small or very large scales. It can also be video presentations, demonstrations, or surfacing patterns in data. Number 6, a good anchor can be a case or a wonderment, like pine beetle infestation, building solution to a problem, or I wonder why rainwater isn't salty. Number 7, a good anchor has relevant data, images, and texts that students will engage with in a range of ideas that they need to explore to understand that phenomenon. Number 8, a good anchor allows students to use a broad sequence of science and engineering practices to learn science through firsthand or secondhand investigations. And then last but not least is number 9, a good anchor has an audience or stakeholder community that cares about the findings or products. That means we are not making things up just for fun. These are real life problems and phenomenon that when investigated, those findings can have or can impact humanity in the future. So during our deep dive time, you'll be starting to develop an agricultural phenomenon using a blank phenomenon outline. We suggest that you use the Beef Phenomenon Toolkit, which again is linked on your takeaway document. If this is newer to you and that process of writing phenomenon is something that you have not experienced yet before. To begin, I'm going to show you how to show you a completed example of a phenomenon outline on your takeaway document, which again has been linked in the chat for you. You will see a worksheet titled Tricky Taste Buds. We are going to use this as an example of how you will start drafting your phenomenon outline. You can go ahead and open that, and I will walk you through my tips and tricks for how to complete your own phenomenon outline during our deep dive time. So again, we'll go ahead and give you a moment to get that opened up. So we're going to do our deep dive here for the last about 20 minutes of work time here. So your task is going to be to complete the phenomenon outline during our deep dive work time. Again, the B phenomenon toolkit that we looked at earlier can help you to fill out the phenomenon box and also that box there that's being pointed to, that explanation box. If you're using something from the toolkit, you can copy those directly from there. If you are working on drafting your own phenomenon, one maybe that you're more interested in, you will need to think through how this statement will be presented for developing the learning experience, and you're going to put that information in the box. You can also copy that explanation of the science of the phenomenon from toolkit. Again, if you're working on your own phenomenon, you're going to have to fill that information in with your knowledge and your research that you're going to conduct. If you're using the toolkit, you can also copy those suggested DCIs. When you're working, you will need to use the SCP and CCC matrices to find how students could interact with and start explaining the phenomenon that you're choosing. Select these based on what you think students should do or think about as they experience this phenomenon. For example, you might want to show a graph or a chart to students and ask them to analyze patterns that are present. If you are drafting your own phenomenon, you will need to identify the DCIs for the experience that you want to provide to students. When you get to your breakout room, you will be with teachers in your grade band. You will be drafting a phenomena outline. You can work independently, or if you prefer, you can work together with people from your group. You'll notice the stars that are on the screen. Let's talk about what each of those sections will require. Stimuli is the specific thing that your students will observe about the phenomenon. This might be a picture, a video, a questionable Instagram post, whatever it might be, but make a decision about how a student will experience the phenomenon you're selecting. In the related phenomenon problem section, you will look to identify other areas that students might be drawn to that are similar to the identified phenomenon. For tricky taste buds, student might start to think about how taste is perceived in relation to those taste buds that we have on our tongue. They might also already know that there's some kind of a connection between taste and smell. This is where you would put those wonderings on your outline. The next part you could tackle in two ways, depending on how familiar you are with the science and engineering practices and the cross-cutting concepts for the age group that you're working with. If you are not highly familiar, I suggest that you jump down to those and start using those NGSS matrices to identify any that might fit this phenomenon well. Doesn't mean that they're going to be perfect, but any that you think might be candidates. We have linked the matrices to all of the dimensions in the takeaway document, and they're also linked in that blank phenomenon outline document as well. Once you know what dimension elements you'd like students to explore through this phenomenon, start framing out consideration design. As you dig into this, you will want to keep track of any additional resources that you use to generate ideas or understanding. Also consider questions that would be instructionally productive that students might have. Be sure to put those into the respective areas on the outline. Personally, I like to end with the relevancy section. I just think that I frame a better understanding if I know specifically what 3 dimensions and what aspects of those 3 dimensions that learners are going to engage with. So for example, if we are looking for patterns, if we're analyzing data, are we looking at scale? Are we designing a solution? I just like having an understanding of those instructional practices that might influence authenticity for the assignment. So truthfully, there is no right or wrong way to complete this outline. So really all we need you to do is just do whatever is best for you in your practice. So I know I just threw a whole lot of information at you. So I'm just going to do a quick little recap there. You're going to take a phenomenon idea, it can be any that we've looked at tonight, it can be one of your own, and working through the process of developing an outline so that you can turn it into something that's instructionally productive for your classroom. So again, we suggest using the phenomenon from that toolkit just to make it easier to complete some of those parts tonight, especially if it is your first time, because you can just copy and paste some of the information from it. You can also refer to the Tricky Taste Buds completed outline to help with what goes in each of those sections. All right, so what questions can I answer before we put you into those breakout rooms and give you some time to get started? Just checking the chat there. Doesn't look like we have anything. So, okay, we're going to go ahead and have you guys get into those grade band breakout rooms. We're going to send you. Again, you can work on your own, or you can collaborate with that group. So just let us know if you have any questions, pop them into the chat, and we will help you if you get stuck.
So on your screen, unlike last time, you have to choose the breakout room that you want to go to. So you have options to go into the K2 room, 3-5, 6-8, 9-12, or if you're an administrator, a curriculum developer, I know somebody's in professional development here, there's a room for you as well. So you'll just go onto the pop-up screen and click join.
And if you wear multiple hats, pick whichever one you want to work in tonight, because we know how it is for you guys as teachers. You wear every hat there is. All right, thanks guys. We'll see you back in about 20 minutes. Okay, it looks like everybody is coming back or back. I can't really tell on my screens. It's not set up super weird tonight, but looks like we're all good. So we just wanted to start by saying thank you so much for being open to sharing all of your ideas with not only one another, but with us tonight, and also just being really willing to learn this process. We know that for some of you, you might already have been familiar with not only NGSS concepts, but the outlining process as well. And we know that it just makes it easier the more you practice at it. We just wanted to make sure to give you that experience of doing so with like that agriculture spin, because again, as we talked about earlier tonight, super important. We know that this process can be complicated. Sarah and I live in this process every day. And there are times when we are just like, nope, we're done. But we recognize how important it is. And we appreciate you for continuing to practice and to continue to work at it as well. Because it definitely does get easier over time as you work in the NGSS space and as you work particularly with phenomenon-based instruction. So we'll go ahead and ask you to drop in the chat. I know some people have already started doing this, but what was the easiest part about working through that phenomenon outline? Yeah, so Cindy put in there just filling out like what the phenomenon is. Yeah, that's, you should probably know that before you get started with the phenomenon outline. I would argue that is very important part of the process. Anyone else have any other ideas or thoughts about something that was easy? Great, yeah, glad that you thought it was well organized. A template is always my go-to to get started, even if I have to. I mean, y'all teach, you can't take anything and just use it as is. So this is yours. You have access to this now. Feel free to utilize it whenever you want to plan phenomenon-based learning experiences. And again, we know that you probably weren't able to get through the entire thing. And so we recognize all of that. So yeah, concept that you haven't used before. Cool. Thanks, Lauren, for that. All right, so we know that when things are easy, they can also be, hard. So what was the hardest part about filling out that phenomenon outline? These are generally the ones I pay the most attention to. And when someone asks me like, what was hard about it? Be ready for a list. So like we're okay with that. So go ahead and drop in the chat something that you felt was difficult about completing that phenomenon outline. Figuring out what to use for your stimulus. Yeah. For some phenomenon, there are so many options, and a lot of times you have to like narrow down those stimuli based on like what DCIs you want to incorporate, because you can take it a lot of different directions. Yep, Carly, you're on it. Yep. What do we want them to get at? What questions do we want them to ask? Yep, Zoom user. I also find staying focused is always tough too, especially when you have to go and do a little research. And we already talked tonight about those rabbit holes. So yeah, fully get that as well. Awesome. Well, thanks again for sharing all of those answers in the chat, and thanks for again sticking with it. I don't know about y'all, but it has definitely been a great night, and we have done a lot of brain work. We just spent basically 2 hours diving into learning so that you can implement phenomenon in your classrooms, or continue to implement phenomenon in your classrooms if you already have done so, but now using relevant topics from agriculture. So hopefully you've learned a little bit about that process for developing potential phenomenon and making them instructionally productive for your classroom. So we definitely appreciate all of your willingness again to share and collaboratively work with your fellow educators here this evening. So one last share in the chat, if you will. We're going to ask you to share in the chat your biggest takeaway from tonight. What was your biggest learning moment? It could be an aha. It can just be a new key idea or term that you learned. And we'll give you a moment to put that in the chat. So again, any ahas or anything. Yep, using the template to help me map out my ideas. Glad that it will be of use. Again, it is not perfect with it. Yep, again, templates. Glad that we can provide some of those. Yes, Kristen, snaps for that one. Definitely sometimes way easier to do just the opposite. Yeah, that sense making wheel is great. That's one of our go-tos to make sure that we are, when we're developing curriculum and ideas, that we are thinking through the entire process for students. That sense making piece is so key and important. Yep. Yeah, I love that. Thanks, Zoom user. Yep. Yeah, NGSS has been around for a long time, and the idea of using that phenomenon-based approach, that inquiry-based approach is really cool. Glad that you were able to see those connections. Awesome. Thanks everyone for putting those things in the chat for us. So we just want to take a moment here at the end of our learning experience to say a thank you to beef farmers and ranchers, because this is that funding for tonight's experience and all of the other ones that we do as well come from them. So we thank you for their continued support. Last but not least, we have a survey that Sarah went ahead and linked in the chat. So before you leave today, you can go ahead and you can take that survey. Again, it will help us to just make our webinars better. I know some of you have been back a couple of times and you've shared some feedback with us. So we'll definitely read through that and listen to how we can improve. But our next webinar, if you are interested in joining us, will be on Thursday, June 22nd. And this one will be a 1-hour workshop from 6 p.m. to 7 p.m. And that is Central Time for the workshop that is entitled Your NGSS Hour, where we'll give you some more tips and tricks for implementing NGSS learning into your classroom. And we'll also give you some space to come off mute and interact with us to ask NGSS related questions that you might have. And we'll try to problem solve answers. In our line of work, we like to call it a scrum session. And so that's kind of what we can do there. So yeah, take a moment, fill out that survey. Again, it's also on your takeaway document for you. I know some of you had asked for that professional development credit. And that's one way that we can know that you were here and that you're present tonight. So we thank you again for coming. I know for some of you super late. So and some of us in the Midwest haven't eaten dinner yet. So I'm super hungry and ready for that. So we appreciate it. We're going to hang out a couple more minutes as we kind of wrap things up. But we hope they have a great night and we hope to see you next time. Thanks, everybody.